So we know what a relation is, but there's special kinds of relations called functions. And a function is a relation where each x, let's say, has exactly one y. We can also state this as in a relation where each domain has exactly one range, or a relation where each input has exactly one output. So let's give you an example of a function. Five, 4, 7, 3, and 2, 6. This is a function. And we can see that because if we made a mapping with x and y, and if I list the domain, 5, 7, and 2, we'll just do it in that order, I can see that the 5 matches with 4, the 7 matches with the 3, and the 2 matches with the 6. That is a function. Let's show you something that's not a function. So let's do 5, 4 again. Let's do 7, 3. And let's do 5, 6. This is not a function. If I make the mapping for this, and if I list the x's, I only have 2 of them, 5 and 7. And then 4, 3, and 6. 5 matches with 4. 7 matches with 3, but we see that 5 also matches with 6. And that can't happen to be a function. If we put an x value into a function, we should only get one y value. Otherwise, it's not a function. And you'll see that when we begin to look at some graphs. Let's take a look at one more scenario. Let's say we have 1, 7. Let's say we have 2, 5. And let's say we have 3, 7. This is a function. If we list the domain 1, 2, and 3, and we list the range 5 and 7, 1 is paired with 7, 2 is paired with 5, 3 is also paired with 5. That's okay. Because to be a function, every x can have only one y. So how do we tell if something is a function or not? Well, using a graph, we can use what's known as the vertical line test. So let's say we have a function on an xy coordinate plane, and let's say that this function looks like this. Okay, if I can put a vertical line and only touch one point, then it's a function. So this vertical line only touches that one. Just touches that one. Each vertical line only crosses one of the points. So yes, this is a function. Second example. Let's draw some dots again. And let's try it again. If I begin to draw my vertical lines, you see that right here, I had this blue point and this blue point, and they have the same, the x value has different y values. So maybe right here, this point is -2, -1, and this point right here is -2, 2. So you have x values that have multiple y values. So this is not a function. Now we can also look at it from the standpoint of just some continuous graphs. So let's say we had this function. Just gave it away. This is a function because each vertical line touches the curve only once. So that's a yes. But let's make a no. A circle is not a function because we could put a vertical line through it, and right there, among other places, each x has a different y value. Now, with functions, we can begin to name equations differently. You know, we're kind of used to, don't write this down, but y equals 5x minus 1, y equals 3x plus 2, y equals 4x minus 5. And somebody comes along and says, well, x equals 5, I want to know what y is. Well, which equation do I use? I don't know. So, what we can do is we can name functions differently using function notation. So let's say we have f of x equals 3x plus 2, and we have g of x equals -5x. And somebody comes along and wants to know what the value of f of 5 is and g of -1, let's say. Okay. Well, the f of x that you see here is kind of like the y value. In fact, it is the y value. We're just naming equations differently because they are functions. We know that each x will have exactly one y. So what this means is every time I see an x, this is my x value. 5 is my x value, and I'm going to use this function. So I'm going to put this 5 into this function for x. So that'll give me 3 times 5 plus 2, which is 17. Now what that does for us is it gives us an ordered pair for that rule, or that function. So 5 comma 17 is a point on that graph. Now g of -1 means to put -1 into the g function. So it's going to go, we'll take a roundabout way right there. So I'm going to have -5 times -1 is 5. So x is -1, y is 5. -1 comma 5 is a point on that graph of that function. You'll see both notations. If we see x and y, it's typically not a function. Okay, or we're dealing, or the specifics as far as whether it has to be a function or not there. If we see f of x and g of x, then we know it's a function, that each x does have exactly one y.